Okay, so moving to the next part. So in the previous part we have finished part number 10, which is learn the properties of definite integration, then find the critical points. Now for parts 11 and 12 we already solved these questions before. You can find them in question 2, part 2 and 3, questions from 7 to 22. Okay, so that's it. So in here, find the critical numbers. Questions 7 to 22, we already solved these questions. So moving directly to part 13, which is identifying increasing and decreasing intervals in the given function. So these exercises will be from 11 to 20, page 267. So let's start with that. So in here, let's take different questions. So let's start with the polynomial function. So what if we have polynomial function? The same steps, which is finding first of all the domain, then f prime, etc. So in here, for the polynomial function, the domain, okay, let's choose the green. So the domain, it will be R. Okay, so I'm solving question 11. So then moving to the next part, which is finding f prime. So this is for x cubed plus, and here this is 12 x to the power 2. Then make f prime equal to 0. This is our next step. So now you can factorize this using the calculator or the manual method, which is taking x squared and 4 as a greatest common factor. So 4x squared outside, that will leave me with here x plus, from 12 I took 4, so I have a 3 equal to 0. So now finding the zeros, x squared equal to 0. Okay, so that will give me x equals 0. And from the second one, x plus 3 equals 0. That will give me x equal to minus 3. So now I will check if they are included in my domain or not. The 0 is included and minus 3 is included as well. So all I have to do is just graphing the number line. Okay, and I'll put my values over here, starting with minus 3 and the second one, which is 0. So I will test the values and substitute in the derivative. So over here you can use your calculator for doing this. So my derivative is alpha, or 4 alpha x to the power 3. Be careful, we have to substitute in the derivative. So plus, okay, and then we have 12, okay, 12x squared, so alpha x squared. So now calc, we need value less than minus 3, so let's substitute, for example, minus 4 to see what is the answer over here. So in here, the answer, once it's equal to minus 4, is equal to minus 64. So this is negative. So let's see a value between minus 3 and 0. So negative, the first one, the second one, this is going to be equal to, so once you substitute minus 1, this is positive. Okay, so negative, positive, then we have what? Okay, I'm substituting 1. Okay, so that's it. So in here negative, in here positive, and in here positive. Now if you substitute manually, it will be the same as well. So in here I will substitute the 1, it will be positive for sure. In here minus 1, minus 1, in here it will be square, so 1, this is 12. 12 multiplied by 1, so this is 12, and in here minus 1 multiplied by 4, this is going to be in here negative, but in here 12 minus 4, this is going to be at the end positive. Now for value less than minus 3, it's negative. So in here it's going down, up, and up. So I will write the increasing interval is from minus 3 to 0, union with 0 to infinity. Okay, and the decreasing interval, it will be from minus infinity until minus 3. And that's it. If you would like to find the critical numbers, or already these numbers are critical, 0 and minus 3, if you remember what we have done before. So that's it. That's it. This is the end of question 11, which is included by polynomial. So let's see if we have another question. Let's say if we have exponential. So in here, if you have exponential, so first of all, you need to find the domain. Now this is x over e to the power 2x, and we said we cannot make e to the power 2x equal to 0 for finding the zeros of the denominator. So this is rejected because we need to take len for both sides, and the len of zeros undefined. So in here the domain, it will be from minus infinity to infinity, which is r. Okay, so starting with finding the derivatives of a prime or dy over dx is equal to, this is a product of two functions. The derivative of the first one is 1, and in here e to the power minus 2x, then plus, I'll put back the first one again, then the derivative of the second one, the same exponential function multiplied by the derivative of the exponent, which is minus 2. So now simplify this. Let's take e to the power minus 2x as a greatest common factor. Okay, then multiplied by, in here we have inside 1 minus 2x equal to 0, making the derivative equal to 0. So from this, e to the power minus 2x equals 0. This is rejected. From the second one, I have 1 minus 2x equals 0. So that will give me at the end in here 1 plus, okay, so this is going to be x equal to 1 over 2. That's it. Okay, so next we'll learn how to solve or how to find the increasing and decreasing intervals. So this is the number line. Okay, don't forget to check. Now 1 over 2 is included in my domain, so it's a critical number. So I'll put 1 over 2 only. Okay, then I'll substitute in the derivative directly. So in here, going to the calculator, I'll write the function, the derivative, sorry. So this is e to the power minus 2 alpha x. Okay, and then multiplied by 1 minus 2 alpha x. Then close the interval, then calc at value greater than 1 over 2. This is going to be 5, for example. So this is negative, as you can see, and a value less than 1 over 2, which is 0, for example. We got 0, 0, 1, 0. Okay. So this is positive. So positive, then negative. So that's it. This is positive, then negative. So I will write the increasing interval is from minus infinity to 1 over 2, and the decreasing, it will be from 1 over 2 to infinity. That's it. That's it. So this is the solution, or how we can find the increasing and decreasing intervals. We will see how we can do this and the inverse functions and the rational functions, square root, and in here if we have power functions, or if we have also exponential, we already solved the question like this time. Okay, so next video inshallah will solve these questions 15 and 16.